In this video, I'll talk about the trigonometric substitution. Okay, so in the past you have seen the U substitution, meaning that you will consider certain term or certain function equals to U and then find out the derivative and replace all the x terms using the U in the integral. Next we learn integration by parts, right? That is another technique of integration, where if you have a function, the integrand, the function inside the integral as the product of two functions, then you use integration by parts or the product rule, right? So now what we are going to do is we are going to learn about the trig substitution. Some of the problems, some of the integrals, it is very hard, very complicated to use the other method like U substitution or integration by parts. It will be very complicated. Like you will have a fractions, you have x in the numerator and denominator, so integration by parts doesn't work, substitution method doesn't work. In that case we will use if U substitution doesn't work, integration by parts doesn't work, then you try the trig substitution. That might make the problem a lot easier. Okay, so but trigonometric substitution are the methods. When you use it, you will have to change to the trig functions and then come back to the original x function. Okay, so you will have to do that. So it is a little bit of work. So let's see one example I'm doing. So before doing the example, what is the method? How do you know what trig function should we plug in? Should we substitute? That is a very important thing. Okay, in the U substitution, we didn't have a certain rule to what to put for U, right? But in the trig substitution method, there is certain rule. If the question has a function like this, a square minus x square, or you might see under the root a square minus x square format, in that case you substitute x equals to a sine theta. X equals to a sine theta, right? Or if the function, if the integral has a square plus x square form, then always use x equals to a tangent theta. Okay, if there is a square minus x square, use x equals to a sine theta. If there is a square plus x square format, then you just plug in x equals to a tangent theta. And if there is x square minus a square, not a square minus x square minus a square format, then you should plug in, you should substitute x equals to a secant theta, and you will have to find the derivative. You will have to do that, but that's the substitution you will have to use. Okay, so when we do the example, then you will be clear about that. All right, so let us do the first problem. That is question number 6. First example is question number 6 from the book. We have x cubed over under the root 16 minus x square. You see that there is a square minus x square form, a square minus x square. That is a 4 square minus x square form, because 16 is 4 square, right? So you can think of that format. So meaning you will have to plug in x equals to a sine theta. Okay, let x equals to a sine theta. Instead of x, we will be plugging in a sine theta. But how about in terms of instead of dx? So let's find out the derivative. Dx will be a cosine theta d theta, right? So if you find out, if you plug in x equals, if you substitute x equals to a sine theta, then dx, the derivative will be a cosine theta d theta. Okay, let us plug in that. So the integral I is equals, I'm assuming that as I, equals to x cubed will be a cubed sine cube theta, because x cubed, x is a sine theta, so x cubed will be so x cubed will be a cubed and sine cube theta. Okay, and what is dx again? Dx is times a cosine theta and then d theta. Divide by, what do you get there? Oh, by the way, not a though. A is 4, right? So we'll do a equals to 4 there, because a is 4. How do I know that a is 4? Because it is like a square minus x square. That is a 4 cubed and then sine cube theta, and then 4. By the way, that should be 4 as well, right? 4 sine theta, 4 cosine theta. So 4 cosine theta and then d theta over, what do you get in the denominator? There is 16 minus x square will be 16 sine square theta, right? Sine square theta. You see that? So continue here. That is, how much is 4 cubed? Is 64 times 4 is there, right? So 64 times 4 is 256. Okay, and then integral sine cube theta, and then cosine theta, and then d theta. Okay, divide by, what do you get in the denominator? Let's take 16 out. If you take 16 out, what do you get? You get 1 minus sine square theta, and then that's it, right? So what do you get? 256, and then there is sine cube theta, and then cosine theta d theta, divide by, there is 16. 1 minus sine square theta is cosine square theta. Okay, so what do you get after that? 256, and then let me copy the same thing in the numerator. Sine cube theta, cosine theta d theta, divide by 4 times cosine theta. That's what you get. Okay, you see that cosine theta divided by cosine theta will be 1, and then 4, I'm dividing that by 4. What do you get? 64. Okay, so what is left there is 64, and then there is sine cube theta d theta. Do you remember how did we find the derivative of sine, entire derivative of sine cube theta, integral of sine cube theta? What I did there is 64 was there, and then I did sine square theta, and then cosine sine theta d theta, right? Sine theta d theta, which is equals to 64, and then you write 1 minus cosine square theta, and then times sine theta d theta. That's what I found, right, in the 8.3. So let's set, again we need to do u substitution. So u equals to cosine theta, then what do you get? Du will be what? Du will be negative sine theta d theta, right? So you see that? So that is sine theta d theta will be negative du, right? So what is the integral then? Integral can be written as 64, 1 minus u square, right? And then times negative du. That is given as negative 64 integral 1 minus u square. This is a little long, right? Du, but this is not hard at all. Now find out the integral. What do you get? Negative 64 times u minus 1/3 u cubed, right? Plus c. Because the integral of 1 is u, and integral of u square is 1/3 u cubed, right? So what do you get there? Negative 64 times, what is the value of u? Cosine theta. So you see cosine theta minus 1/3 cosine cube theta plus c. Now you see that our question was in terms of x, but our answer cannot be in terms of theta. We need to go back to in terms of x. Okay, so how do I do that though? You see that you have x equals to what? X equals to 4 sine theta, right? What is sine theta then? Sine theta equals to x over 4, right? But what is the sine in the, if you make a right triangle, then sine is perpendicular. Suppose this is theta, okay, perpendicular over the hypotenuse, right? So that is x, that should be 4, right? That is like p over h. So p is x, and then h is 4. What should be the b then, the base? What should the base? Base would be h square minus x square, right? So 4 square minus x square, that is the base. You see that? So you see the sine is perpendicular over the hypotenuse, right? So the cosine should be the base over the hypotenuse, right? Ratio of the base and hypotenuse will be the cosine. So what you can write on that is negative 64 cosine is under the root 16 minus x square over 4, right? Minus 1/3. So cosine cubed is that the cube of the root, right? Because cube of that over that. You see that? Cube of this over that. That will look like what? So that will look like, let me write down that 16 minus x square over 4 to the cubed plus c. Are you guys okay with that? I'm just plugging in the value of cosine theta because sine theta is x over 4. So cosine theta will be that over that, base over the hypotenuse, right, in the right triangle. That's what I was doing. So now this can be written as, I can take that 16x squared over 4 out. If I do that, negative 64 times root under 16 minus x squared over 4. If I take that out, what is left is 1 minus 1/3 the square of that left, right? So that will be 16 minus x squared over 16 is left. Do you agree with that? Plus c, because there were 3 of them. I took 1 outside, so 2 left, but there is a square root. So square root of square will be just the 16 minus x squared over 16. So what do you get? That is negative 16, because I divided that 64 by 4. Negative 16, right? And then under the root 16 minus x squared. So under the root 16 minus x squared, right? And then what do you get? 1 minus 16 minus x squared over 48. 16 times 3 is 48 plus c. If you want to further simplify, you want to make the same denominator there, right? So what do you get? You get negative 16 under the root 16 minus x squared, right? And then you get 48 minus 16 plus x squared divided by 48. That's what you get, plus c. Okay, now you see that 48 you can again divide by 16, so you get that, right? So sorry, not 4, 3. That should be 3, right? So what do you get? What is the final answer look like? Negative under the root 16 minus x squared, right? And then that is 32 plus x squared, that is x squared plus 32 over 3, right? So the final, very final answer is negative 16 minus x squared and then x squared plus 32 over 3 plus c. That is the final answer. So it's a little bit of work, but it is not bad. So we did the substitution twice. At the beginning here, we did a substitution here. That is the trig substitution. But after we finish the trig substitution, you see that we got sine cube theta, and then we did sine square theta, and then sine theta, and then 1 minus cosine square theta times sine theta. And then we did the u substitution after that. Okay, trig substitution and u substitution, and then we finally got the answer. So if you don't have that, if you don't know this method, or if you don't use this method, this problem will be hard to do. Okay guys, so the next problem that I want to do is question number 8 from the book section 8.4. okay, so this problem has x squared minus 25. okay, so as I mentioned earlier, if you have a squared minus x squared, you do x equals to a sine theta. But if there is x squared minus a squared, you have to do x equals to a secant theta. Okay, if there is x squared minus a squared, you can write like this one as like x squared minus 5 square, right? So this is like x squared minus a square form. So it can be done by using set x equals to 5 secant theta. Okay, what will be dx then? Dx will be 5 secant theta tangent theta and then d theta. That's what you get, right? Now so what we do is we plug in back. Okay, so all these values, so what do you get there? Then this will be equals to integral under the root x squared is 25 secant square theta minus 25 divided by 5 secant theta times, what is the dx? Dx is 5 secant theta tangent theta d theta. You see that? Now what do you get here? You can divide the 5 secant theta and 5 secant theta cancel out, right? What is left is under the root you have 25. Take that 25 out, you get secant square theta minus 1, and then times you have tangent theta d theta, right? So what is secant square theta minus 1? That is 25 tangent square theta times tangent theta d theta. See that? So that is equals to integral, this is 5 tangent theta, because the square root of 25 is 5, square root of tangent square theta is tangent theta, right? Times tangent theta d theta. Okay, now you can write that as 5 outside tangent square theta d theta. Do you know how to find out the integral of tangent square? You need to change to secant square. So secant square theta minus 1 and then d theta. So what is the integral of secant square theta? That is tangent theta. And what is the integral of 1? Is this theta, right? You see that? Because we are finding in terms of theta. So it is tangent theta minus 1. Now the question is, how do I, because our question was in terms of x, but we got our answer in terms of theta. So we need to go back to x. How? Because you see that from here, x equals to secant theta, right? 5 secant theta. So if you divide by 5, you get secant theta equals to x over 5. But if you make a right triangle, that's a right triangle, right? Suppose this is theta. So secant is, you know, the hypotenuse over the base. So that is the hypotenuse. This is the base. So hypotenuse is x, base is 5. So what should be the perpendicular? What is the opposite then? The opposite will be x square minus 25, right? Because it will be h square, hypotenuse square minus the base square under the root, right? So that will be, so the perpendicular, the opposite or perpendicular is under the root x square minus 25. Okay, now you see that what is tangent theta? Tangent theta is, so tangent theta is perpendicular over the base, right? The ratio of the perpendicular over the base, that will be under the root x square minus 25 over base is 5. That's what you get. Okay, let's plug in back. And how about the theta though? Also you can see that, so theta, so secant theta equals to x over 5, theta equals to secant inverse x over 5. That's what you get. Because if you multiply, if you take secant inverse on both sides or arc secant on both sides, that's what you get for theta. So what is the final answer then? Therefore, hence the I, let us say that this is I, the integral I equals to 5. Tangent theta is under the root, oh by the way, the under the root is only on the top, right? X square minus 25 over 5, and then minus theta is secant inverse x over 5 plus c. That's what you get. That is the final answer. Okay, so this was not very bad, but it is kind of long. But here you didn't have to do the substitution twice like in the previous example. Okay, so the next thing I want to do is question number 14. That is also slightly different than what we did. Question number 14 here. Okay, on question number 14, the question is find the integral of 2x square over, you have 4 plus x square, 4 plus x square to the square and then dx. You see that the formula that I gave you there is, if you have a square minus x square, then you do x equals to a sine theta. If you have x square minus a square, then you do x equals to a secant theta. And if you have a square plus x square or x square plus a square, it's the same thing. In the minus, if you put that a square on the first or second, they are different. But in case of the plus, you can write x square plus a square plus, or a square plus x square, not a problem. X equals to a tangent theta. Okay, here you can write that as 2 square plus x square. It is like a square plus x square, right? So what you need to do there is set x equals to 2 tangent theta. If you put x equals 2 tangent theta, what do you get dx then? Dx will be what? Dx will be 2 secant square theta d theta, right? Because the derivative of tangent is secant square theta. Now we plug in, let's suppose that this is I. Now let us plug in and do it. So I equals to integral 2 times 2 tangent theta square will be 4 tangent square theta times what is dx? 2 secant square theta d theta. That's what you get in the numerator. In the denominator you have 4 plus 4 and then tangent square theta whole square. That's what you get, right? Now what you get then is, if you multiply all those, you will get 2 times 4 is 8 times 2 is 16, and then integral tangent square theta secant square theta d theta divide by, what do you get here? 4 plus 4, you take out 4, what do you get? You get 4 1 plus tangent square theta and then square, right? So what do you get? How much is that then? It is 16, and then integral tangent square theta secant square theta d theta over, that will be 16. 1 plus tangent square theta is how much? Secant square theta. Okay, 1 plus tangent is secant. Why? Because we know that secant square x minus tangent square x equals to 1. If you add tangent square x, you will get 1 plus tangent square x equals to secant square. So it will be secant square, but there is square, so it will be secant fourth theta. Okay, now you see that you can cancel that secant square and one of the secant square there. If you do that, what do you get? Oh, by the way, there that 16 and 16 also cancel out, right? So what you get is, you get integral tangent square theta d theta over, you got one of the secant square, right? Secant square theta, the secant square, because that is secant 4 theta. If you do secant square times secant square, you cancel one of the secant square with the top secant square, and that's what it is left. Okay, so do you know what is tangent square theta over secant square theta? Let us try that, because it is tangent is sine over cosine, right? So you can write this as like tangent square theta over secant square theta, right? Let me write down the top part is basically, it is like sine square theta over cosine square theta divide by secant square is 1 over cosine square theta, right? But if you write in the product form, you can write sine square theta over cosine square theta times cosine square theta over 1, right? And you cancel that cosine and cosine. What is left is just sine square theta. Did you see that? So you write down that way. If you write that way, what do you get? Integral of sine square theta d theta. But how do I find out the integral of sine square? We need to write in the cosine 2 theta form, right? That will be integral of 1 minus cosine 2 theta over 2 d theta. Okay, that will be, let me take that 1/2 out. What is the integral of, and then find the integral of that. What is the integral of 1? It is theta minus integral of cosine 2 theta is sine 2 theta over 2. Okay, and then plus c. Now what is the formula of sine 2 theta? Do you remember that? That is a multiple angle formula, right? So you can write 1/2 theta minus 2 sine theta times cosine theta over 2. That's what the sine 2 theta means. 2 sine theta and then times cosine theta. Okay, so what do you get? That is basically 1/2. That is, by the way, that should be 1/4 when you multiply by 1, right? So what is left is 2, because that should be 1/4, and you are cancelling out 2, and then what is left is 2. Okay, so basically what you got, the final version will be 1/2 theta minus 1/2 sine theta cosine theta. Okay, now is this the final answer? No. Why? Because your question was in terms of x, your answer cannot be in terms of theta. So what you need to do is go back and then see here. You assume that tangent theta is what is tangent theta from here? If you write down here, tangent theta is how much? X over 2. If you divide both sides by 2, right? You cancel that 2. So tangent theta is P over B, perpendicular over the base. That is x. This will be 2. So what should be the hypotenuse then? X squared plus 4. That is the hypotenuse, right? So you see that sine theta is 1/2. Let me write down what is theta 2. So theta will be tangent inverse x over 2, right? That is theta. If you take arctan on both sides, that's what you will get. Theta equals tangent inverse x over 2. So tangent inverse 1/2 tangent inverse x over 2. That is theta value minus 1/2. What is sine theta? Sine theta is perpendicular over the hypotenuse. That is x over times x over under the root x squared plus 4 times cosine theta is base over the hypotenuse. That will be 2 over under the root x squared plus 4. That's what you got. Okay. So basically the final answer will be 1/2 tangent inverse x over 2. Right, that 2 and that 2 will cancel out, minus x over, what do you get? If you multiply that square root and square root, you will get x squared plus 4 plus c. Don't forget plus c. This is the final answer. Okay guys, so I will do a few more examples in the next video, but this is how you do all the problems here. All right.